As you move out of elementary arithmetic into the abstractions of Algebra 1, you're going to want to know about the different sets of real numbers and understand why we use a real number system. First in the set of real numbers are natural numbers. These are our basic counting numbers. If we use braces here, we can show this set of natural numbers as 1, 2, 3, so on and so forth until infinity. Whole numbers contain the set of natural numbers, but they add a very important new concept, the concept of zero, nothingness, or emptiness. So if we use braces to express the set of whole numbers, we have 0, 1, 2, 3, so on and so forth, also moving into infinity. All natural numbers are whole numbers. The one whole number that is not a natural number is the number 0. Moving past natural numbers and whole numbers to talk about the other sets in the real number system, we move on to integers. Integers add a new level of complexity because now our number line can go in more than one direction. Integers express the set of positive numbers, negative numbers, and 0 with no fractions or decimals. We would write the set of integers using braces. 3 dots showing we're moving in infinity in the negative direction, -3, -2, -1, 0 is an integer, and then we have 1, 2, 3, and again, we're moving in the direction of infinity here. All whole numbers and natural numbers are integers. Rational numbers are extremely useful because they allow us to see the spaces in between our integers or in between our whole numbers or natural numbers. Key word in rational numbers is this idea of a ratio. Rational numbers are a ratio of two integers. So numbers like 3/5 or 2/7 or -5/4 are all rational numbers. Terminating decimals like 0.3 are rational numbers because the way we can express this as a ratio of two integers is by writing it as 3/10. Whole numbers like 5 are rational numbers because this ratio of two integers is 5/1. All integers, whole numbers, and natural numbers are also rational numbers. So the last set of numbers in the real number system are called irrational numbers. These are numbers that cannot be expressed with a ratio of two integers. Most famous irrational numbers are numbers like pi or the golden ratio. We'll save those for another video. If you're having a little bit of trouble remembering what all of these symbols represent, go ahead and rewind a few seconds back in the video to see the diagram we had where you have natural numbers represented by n in the innermost circle, whole numbers represented by w in a slightly larger circle that contains the natural numbers, z represented integers, which is a slightly larger circle containing both whole numbers and natural numbers, and then q represented rational numbers, or a ratio of two integers, which was the largest circle so far in our real number system. We're going to ask about each of these numbers specifically. So for the number 3, we want to ask, is it a natural number? Absolutely it is. It's one of our basic counting numbers. It is also a whole number. There's no fractions or decimals. It is an integer, and it's also contained in the set of rational numbers. People don't see this as a ratio of two integers oftentimes, but we need to understand that 3 can be represented as a ratio of 3:1. And for that reason, it's considered rational as well. Let's talk about -7. -7 is not contained in the set of natural numbers, nor is it considered a whole number because whole numbers do not contain the set of negatives. It is an integer, and it is rational because -7 can be written as the ratio -7/1. 2/3, our first fraction here. Not a natural number, not one of our basic counting numbers, definitely not a whole number. It's not an integer because integers do not contain fractions or decimals. It is rational. Our ratio is 2:3. Similarly, we can look at -4/5. We know it's not natural, it's not whole, it's not an integer because integers do not contain fractions or decimals. It is rational. The ratio of -4/5. The number 19, a slightly larger natural number, once again is natural. It is whole, no fractions or decimals. We can call it an integer. And we can call it rational because 19 can be written as the ratio of 19 to 1.